I audible? Good afternoon, and thanks, Dr. Vijay, if he's still around. I think he touched on some of the very basic and core issues that we face today. And I'm again, I'm given about 15 to 20 minutes to talk about artificial intelligence and its role in healthcare. And I'll try and get some introduction done in the meanwhile as well. So as a way of introducing myself, I'm a technologist first and a healthcare enthusiast as well. And I'm, as a coincidence, very privileged to lead IBM's healthcare mission, which is called Watson Health. That's for the country, and I also lead the Watson Health implementation and delivery for about 40 of our clients across APAC. So as we move forward today, let me introduce the concept of AI, and I'm going to be interchangeably using the term artificial intelligence and cognitive together. That's because cognitive, which is what we believe, is a subset of AI, but is what's more relevant to how you apply AI in healthcare. So do not get confused. So AI and cognitive for me is the same thing. Why use it, first of all, right? So as you can see and imagine today, what that chart is telling us, information or data, which is the foundation for everything today, is disrupting every single profession. It's not only healthcare alone. It's, you talk about banking and financial services, insurance, retail, advertising, fashion, everywhere, right? We're getting a lot of data coming from a variety of sources, from your, the health gadgets that's being put into human body, from newspapers, from social media, from emails, from text messages. Talk about it. So it's in a way disrupting our lives and every single profession. So so as you can see, the data that is coming from all of these new age technological sources is of varied type, right? So what you see on the left-hand side is what most of the people are familiar with. If you programmed like me 20 years ago, 22 years ago, you'd know how to deal with that kind of data, right? Which is very structured in nature, stored in databases, and you can apply traditional programming techniques to make sense out of that data. On the right-hand side, what you see is a combination of all kinds of data. Data that is coming from image files that have embedded text in them, text messages, messages coming from instant messengers like WhatsApp, or data that is coming from your Fitbits in your body and watches, apps in your mobile, from all sources. So that type of data is traditionally very, very difficult. Typically it's very difficult to program through. So that's essentially is the challenge, and it's coming from all sources. As I said, you look at your body itself, or we look at our body ourselves. That itself is what's called the source of big data for us now. In the healthcare world, if you imagine a patient that just underwent some sort of a surgical procedure, maybe putting a stent because they had a block in their arteries, they go back home or to remote care. There are tons of gadgets plugged into their body that's possibly reading all sorts of critical parameters, blood pressure to glucose levels to pulse rates to many of these critical parameters. Now these parameters, as you can imagine, they come in variety of forms, right? And they get stored somewhere. Now imagine there's just one patient generating data in form of gigabytes, right? And imagine about millions of patients in the world that are generating this sort of data. And how do we deal with it? So, I'm going to present three very compelling facts in front of you why we are kind of forced to use this shift in technology, AI, artificial intelligence or cognitive. Healthcare data, right, today is estimated to be about 150 exabytes. That's massive. And that's not it. It's really doubling every couple of years. Why? Because what I told, it's coming from all kinds of sources. The Fitbits, the apps in your mobile where you're feeding in data, various gadgets, and all of that. So it's doubling every couple of years. That's the data explosion that we're talking about. Now, most of this data, because of the very nature or the source from where they're coming, they are voluminous, they are also complex, they're also unstructured in nature. So that's the unknown we are talking about. 80% of the total healthcare data that we see today is unstructured. Images, scans, x-rays, and all of that, right? And if you look at a chronic disease like cancer, right? Today, we are not done with 2017. We're just about 10 months done. There are roughly 44,000 oncology research papers that are out. Okay? That's massive. Now, in a country like India, if you imagine, where the typical doctor-to-patient ratio is about 1:1,600, an oncologist typically have less than 15 minutes, less than 15 minutes, to go through a patient's case history, his current set of medical data, and recommend a treatment procedure, right? When they have that kind of acute shortage of time, and what this is telling us is if they were just to read all the research papers that have been published on oncology this year, they would need about 29 hours a day to read them. How contrasting is that, right? So at one hand, we have less than 15 minutes for every oncologist to see and diagnose and recommend treatment procedure for a cancer patient. On the other hand, we are requiring them to read about 29 hours a day to stay current with the information that is coming. That's very compelling in nature. So imagine if we had an assistant or some sort of somebody that would be able to crunch through the massive amount of data that we just talked about, the 150 exabytes of data that we have in healthcare today, which is doubling every couple of years. Make sense out of that, derive patterns, generate recommendations with confidence percentage that tells the oncologist about how confident the system is about a particular method of treatment that it is recommending with evidence. So it is very transparent in nature. And imagine, while it actually crunched through all the data, it also found time to read through, ingest all the information that is coming through the research papers, the knowledge bodies, and all of that, right? And while it is doing that, understand the source of data that we are talking here is unstructured. And it is able to read through that unstructured data, which is 80% of the total healthcare data I said is unstructured. And within the flash of a second, is coming back with a set of recommended treatment options with a prioritization, with a confidence percentage that is able to suggest the oncologist keeping everything together. That is really augmenting human brain. It is humanly not possible to do that. This is a very compelling fact. And the assistant that I talked about, in our world, we were really saying that's the cognitive assistant, that's the AI assistant, that's the power of AI for which we need to use it, we need to adopt it. Now, while I'm talking about that, I'm sure most of you are somewhere or other related to some kind of profession in healthcare. So you know most of this, right? But I'd like to give you a quick real life example of how using AI or cognitive, we are going to move from this massive foundation of data to wisdom, which then can be applied to a given problem. So we look at the data. You take an example of you're driving through the roads of Bangalore, right? And the data that is sitting there is telling us some coordinates. it's also telling us it's red. That's how data looks like, right? It's unstructured, and it is telling us some coordinates. We aren't able to make sense out of it. Then you look at the information, which is providing it a meaning. The meaning is there is a south-facing traffic light, south-facing from where you are, on the corner of the Brigade Road that is going to turn red right now, right? And you would then have knowledge and a context applied to it, which is saying the traffic light that I am driving towards, because it is telling you in the context of what you're doing, the traffic light that I am driving towards is turning red. From where you get the wisdom, you're applying, which becomes actionable. Red light means I better stop the car. That's the application of cognitive or AI in a real-world problem, in a very basic sense. Now, let's look at how we apply that to healthcare, right? So what we're calling it as a digital health pathway. So same data information layer. The information that you saw there in the real-world example, which were the coordinates in the red light, right? That is sitting as your electronic health records, right? Or the EMRs, or the patient case history and all of that. That's very raw. Now, you have a descriptive layer, which we still continue to have since past 10, 15, 20 years, right? Nothing new. It provides the meaning. That means we have these various dashboards, reporting, and all of that. And then you get the knowledge out of it, which is the artificial intelligence aided or cognitive analytics. It's providing it's a context, right? And then you get the wisdom from it, which becomes actionable. You're using machine learning and deep learning over there to help guide a user experience. To specifically talk about these layers, in the information layer, you're really talking about the data governance, the structured, unstructured data, how you store them, where do you get them from. In the descriptive layer, you're really talking about the clinical and operational dashboards. In the knowledge layer, in the analytics layer, you have predictive and prescriptive, which we've always had. The new thing is the cognitive one that I'm talking about, which is the understanding of the data applied to a context and suggest you possible actions and the outcomes of those. That is how you apply it to healthcare. It makes sense, right? So, what do we call it? Digital health pathway is nothing more than applying that new layer that we are talking about today. That's where our world is moving. Now, as you can see, the AI systems or the cognitive systems that we are working on now, why they are so powerful? Because they got these basic characteristics. They are able to interact with the various systems, human beings, in a very humanistic way. They can understand visuals. We can do voice to text or text to voice. So they can interact. They can understand, as I said earlier, they can understand massive amount of unstructured data. For example, the IBM Watson system itself, it can read 300 million pages in a matter of 7-8 seconds. That's powerful, right? It can read and understand, and it can reason to. It can break down each one of those, connect the dots, deduce the patterns, derive the insights, come back with a recommendation based on what it knows. These systems understand. I'll give you an example. When we started building the Watson for Oncology system, right after 2011, when Watson won the Jeopardy game, so MSK, Memorial Sloan Kettering Hospital in New York, they were the first ones to bring their massive data sets about oncology, their patient case histories, patterns, successful treatment options based on genetics, and loaded that into Watson and taught Watson how to teach, how to treat cancer, how to diagnose, what to recommend, how to connect the dots based on the input, right? So those systems have to be made smarter too, and they have been. Now, so when the cognitive systems, they interact, they understand the region, and over the period of time, they are also getting smarter. They're learning, they're remembering, and they're able to use the past incidences the inferences, the recommendations that they made for usage in the future. So the biggest value you get out of them is after a few years of usage, when you have loaded a lot of historical data into them. So, and I can't think of any other traditional programming systems today that, that can do all of this: interact, understand, reason, and learn. Now, really, really powerful technology. So if you look at, the application of AI or cognitive into healthcare, today we are working with, life sciences and drug companies, pharma companies, to help them expedite drug discovery. To give you an example, when a particular type of drug is conceptualized based on a research, it takes typically about 20 man-years for them to hit the drug counters because of various compliance pieces they need to adhere to and get certified, and FDA approvals and all of that, right? We are expediting that journey through providing a life sciences cloud, which has sort of all the compliance, all the FDA CFR parts built into it, where the drug companies and the pharma companies can actually do their testing to rapidly bring those drugs into market in the order of 1:10 time. It used to take 20 years. Now it is about to take a couple of years to hit them to the market, and that many more lives saved. We are also working with a number of medical devices company. Dr. Vijay spoke about Medtronic. We have partnered with Medtronic, Apple, Johnson & Johnson, for them to use what we call our health platform, cognitive health platform, to build out devices that are much more smarter. We are using those partnerships to build out apps. For example, there was a new app you might have seen called Sugar IQ. You can Google it and look at it. We worked with Medtronic to build that app into life, which actually, Dr. Vijay spoke about management of diabetics, right? It's not only diagnosing it, it's managing it for a long period of time. So we are helping diabetic patients with the usage of that particular app to suggest or to recommend food options, activity options, point in time when they need to get back to a diabetologist to go and get something checked. So the entire management of diabetics. So we are working with device manufacturers. We are also working with, if you look at products and solution space, we are working with more than 80 hospitals across the world on cancer. We are helping oncologists in those hospitals treat hundreds and thousands of cancer patients. In the public health space, we are working with a number of government agencies to help them identify at-risk populations through the application of cognitive technologies and take actions, which is called population health management. All of you know that, right? The payers, providers market. So it's very powerful, really. This is where we're working on building a number of new solutions and use the existing solutions that we have. Now, the three current trends, if you look at the application of AI technologies into health, it's really transforming the health market. Transforming the health market because of the foundational data that we are receiving from all kinds of sources. It isn't possible to use any other form of traditional health tech systems to make sense out of that data. And that data is diverse, right? And I'll give you an example in the India context a little later. Then there are a number of opportunities that we'll talk about as well. But very importantly, the usage of cognitive or AI technologies, it requires engagement. I'll give you an example of what that is. Engagement means there are all kinds of stakeholders. We have to have doctors that are adopting such help or technical help that they are about to get. We have patients, you and me, the citizens, the people who are receiving care, they have to adopt it. We have governments who have to understand the power of these technologies and work towards solving bigger population health challenges with the usage of those technologies. So this means engaged stakeholders. That is very important for the success of AI technologies in this space. Now, let's apply a little bit of India context into it. Why it is important for the AI and cognitive technologies for us to at least start applying them in the Indian context. So if we look at, I picked this, there are many problems in the healthcare sector in India. I just picked this 5, right? Because to me, they are the top most 5 ones. We're the second most populous country in the world after China. 2024 will probably overtake them. We have about 1 billion people here in India and another 250 million probably in the US, right? Most of those that are migrated. So speaking about it, it's a problem of scale. It's a problem of scale. India is also a very diverse country. The whole environment changes as you go from the south of Tamil Nadu till all the way up north in Kashmir from the east coast to the west coast. So diverse geographically, which means the living conditions vary. Diverse religiously, which also means the way we consume care, it varies. Diverse demographically, which also means the gamut of programs, care programs that are needed to solve the challenge of the population, they vary. We also do not have enough doctors. As I said earlier, we have, as per World Health Organization, we have about 1 doctor in every 1,600 patients. There is well below the World Health Organization recommended standard of 1:1,000. That's a massive problem. In India, we also do not have a lot of knowledge or awareness or visibility or transparency into various forms of care that are available to people. That problem is really acute in rural areas. So here really we are talking about the democratization of health information across the masses. Economic inequity, what I mean by that is the divide between the rich and poor in India is quite large, right? So the way the quality of the healthcare that the rich receive and the poor receive is quite different. That leads to a great healthcare divide itself, right? So when you look at all of these problems, and earlier I mentioned how we are using AI or cognitive technologies to solve some of the scale problems, some of the variety problems, which is the diversity. We are solving the problem of lack of time by the doctors for each patient. We also talked about the kind of transparency it brings, because when we use for example, the Watson for Oncology system, we are not really telling the oncologist how to treat a patient. We are not taking that power away from the oncologist. We are augmenting their brains. We are really helping them extend their capacity, so to speak, right? And when we come out with a recommendation from the Watson for Oncology system, it is typically accompanied by like 4 or 5 different recommendations with a confidence percentage, right? So the power really is in the hand of the patient and the doctor to decide the best course of action based on the things that they see, which otherwise they would not have at the time and the ability to go and see. So if you look at all of these top 5 problems that I have outlined, cognitive or AI makes perfect sense for us to some way or other apply in the Indian context. Now, I hope there is a day when I'm sure there are a number of startups here. They are working towards solving some real-world challenges in healthcare, which is the challenge just that I have listed here. There are really opportunities for all of you that are from the startups to innovate and try and solve a real problem here, like Dr. Vijay said, right? And these cognitive or AI systems, if you look at the biggest strength, which people otherwise misunderstand, there are a lot of hypotheses going on right now in the world. If you Google, you'll find them about against AI or cognitive in the world. But to me, the biggest strength, if you use them right, they become their biggest strength, which is, you look at its purpose. Its purpose is, for example, not to take away the power of determination or making a recommendation or providing a treatment option for a doctor to the patient. We're not taking that away. We are only augmenting and enhancing the human decision making through the usage of these technologies. How I told you earlier, right? It also provides transparency. Transparency in the sense that when it provides a recommendation, it is also backed up by years worth of research data. It also provides an evidence in most cases. So you can actually query the system to see if it provides a recommendation regarding a particular treatment option, why it is doing so. You can ask that question. You can query those systems. And most importantly, skills. These systems today in the form are not easy to consume. I'll give you an example. We are working with Manipal Hospital here in Bangalore. When we started, there was, they agreed to work with us. We went live with the system, working with the oncologists to actually adopt the systems, right? Use them for their patient cases. The first question really they asked was, I don't have time. I have less than 15 minutes, right, to look at a particular patient's case history. I really need the data file right in front of me, which is coming from their hospital management systems. Where would I get the time to actually input all the data into that system? We have a button called Ask Watson. But that Ask Watson works only when you have quality data being input into it. So they don't have the time. They don't want to use those systems as such. So we had to find some ways of getting the case files ready in front of them so they are ready to click the button, right? But that solution has to come from them as to what the problem is and how they adopt. So finally, the skill levels, the adoption has to increase amongst the community for all of this to make sense. So that's my message to everyone here, that these systems are incredibly powerful, hard to consume in the beginning, but don't lose hope. They're very powerful, therefore they need to be used in the right way. Do use them the right way. Thank you.